Thank you, thank you. Let's get even closer here. Hi, everybody. I'm Joe Maglitta. I'm a special contributor to VentureBeat. You've met Ameen. He's the head of data science at Zappos. So has this ever happened to you? This sounds like an infomercial, right? So you're searching. Say you go to look for dress shoes out on the internet, and you put in a couple of things, and what pops up? Well, I'm looking for men's dress shoes, right? But what do I see? I see men's dress shoes, but I also see women's dress shoes to go with a dress. Or maybe if I get really far-ranging results, I get a YouTube video from a cosplay site that teaches me how to dress up footwear like Marvel superheroes, right? Because the algorithm doesn't know what I'm looking for. That's a common problem. The big search engines are pretty good at it, but a lot of e-com sites are not that great at it. It's a huge problem at a big site like Zappos that has got a gajillion products. We're going to talk today to see how Zappos over the last couple of years has solved that problem, because it was a problem a couple of years ago.
Definitely. Yeah.
The company has taken itself from being a victim of the kind of thing that we talked about to being really a leading edge, bleeding edge company that's mastered that right now. And they've done that using semantic search. So we're going to talk a little bit about what that is, how they went about doing it, and what that benefit it brings to both the customer and to the company. They've done such a good job. We've noticed it at VentureBeat. There was a story in the Wall Street Journal this week, a couple of days ago, talking about that program. So it's starting to get a lot of traction. So we're going to talk during the brief time we have today about just quickly about what semantic is, what Zappos is doing, why they're doing it, a little bit about how they're doing it, looking at some of the successes that they've done, and what's next.
Absolutely, yeah.
So joining us is Ameen, as we mentioned, who's lead data scientist there. Ameen, welcome, and thank you for joining us. Before we dive into your story, let's just quickly level set for people here, because I think probably some people know a little bit about semantic search. It's been around as a concept since the 70s, but it's just starting to come to fruition now. So I know it's still gelling, but what is your working definition as someone who does this every day? How does it differ from regular search?
So I guess when you think of regular search, the term that comes to mind is like something that's more lexical. You've got your traditional search index, you've got your slew of inventory, and every piece of every SKU in your inventory has a certain number of attributes associated with it. And the most intuitive way to scan through that is having some kind of search index, and then you get a search term that comes in, and it has words in it, and then your search index has words in it, and you look for the words in the search term in your search index, right? And whatever items have the most words from the search term in their dictionary or whatever search index you're using is the one that gets ranked. This is an aggressive oversimplification, but that's effectively what it is. So like dress shoes, we look for, all right, what has the word dress in it? It's dress shoes for men, dress shoes for women, dresses, all have the word dress in it. Salad dressing, the word dress shows up in a lot of places. And then we look for the word shoes, and we're like, all right, there we go. And a big issue you run into with this is you've got product descriptions that are talking about things that the product goes well with, like this dress goes really well with these shoes and stuff like that. And when you look for a purely lexical connection, where you're just counting the number of words that show up in your search index and in the search term, what happens is you do not have access to the contextual intent behind that search term. Like, what was the user thinking when they typed in dress shoes, or when they typed in classic short, right? So classic shorts is another fun example. How many people here know what a classic short is?
For shoes.
Well, if I asked you what a classic short was, you'd probably say, oh, just a classic pair of shorts, or, and that's what most search engines think. But they're actually a really nice boot sold by a company that does really well in sales, and we'd like them to show up when people search for classic shorts, because search is like the first line of defense, right? You come in, you search something, you don't see it, you're like, oh, they don't have it, and they leave, and you leave, right? And we've lost the customer. So when somebody types in terms, we want to know what they are looking for, not just what in our inventory has all the words they typed, right? And that's kind of what I would define the difference between just a standard regular lexical search and a semantic search. At Zappos, we've actually taken it a step further and made the decision that not only is there a contextual meaning behind a search term, that contextual meaning changes on a per customer basis as well. So for the millions of unique search terms you can see and the millions of unique customers you can see, we actually try our best to serve individually unique search results. And I stress on the word individually because it's been a nightmare engineering problem, but we are at a point where it's not collaborative filtering, it's not segmentation, it is a one-to-one understanding of the individual and the term that they've typed. And I got an arbitrary number from my search team saying, hey, if your data science thing can't come back in 50 milliseconds, we're not doing it. He doesn't really sound like that, I don't know why. But that's what it sounded like when he said it to me. But we hit that number. In fact, it's a little faster with a bunch of different engineering infrastructure solutions that we deployed. So we're actually pretty proud of that, where we've stretched the meaning of semantic, not just to what's the meaning of the term, but what's the meaning of the term if it's you, or what's the meaning of the term if it's you. It could change, right?
So it's personalized intent, personalized context, concept, and even potentially natural language.
Yeah, so natural language is something we don't, we do look at natural language, of course, to extract like the words that would belong to the search term. Zappos users haven't got to that stage when they interact with us as a product, where they're conversational in the way they're searching. Like, I'm looking for, running shoes for running on the road, but sometimes they'll be nice if I want to go hiking in them. But we want to get there. We want you to be able to talk to us and us understand the pieces of that conversation that pertain to search. And everything we've designed is extremely modular to where we can definitely go there when the customers need it.
Well, let's back into that. So let's go back in time. I'm sitting here, I'm suddenly conscious of my shoes here, so don't look at them. I did polish them this morning, but
I wore these on purpose, so I want you all to, because it always comes up when you work at Zappos, so you just wear the flashiest shoes you can find.
you have to represent.
Yeah, you got to represent, exactly.
Come see him afterwards. He's got a great Zappos jacket with his team logo on it too, and he'll tell you about what Zappos teams are, but representing well. So take me back to early 2017. I'm out looking for dress shoes, or red running shoes is your example that you use on the Zappos side. What do I see? And tell us a story about how you got from there, which is still the state of the art for a lot of websites, and how you move through the thought process and the doing process to get to where you are today.
So I can definitely talk a little bit about our journey at Zappos. Search was not always a responsibility of the machine learning organization, which is the organization that I lead at Zappos, but it was the search team's responsibility, the one that maintained the search index. The problems they ran into then were it was exactly this. It wasn't a semantic search algorithm. It was purely lexical. And the issues we were running into were dress shoes, classic shorts, things like that, where the only time we'd find out that one of the million unique search terms were not showing the results we'd want them to is when the buyer of that product would be like, I'm searching for the words that the name of my product is, and belts are showing up. And they'd like tell search that, and we'd be like, all right, well, search would be like, we're on it. And what they'd do is they'd create manual hard-coded redirects saying, oh, when it's classic short, go to those boots, don't go to shorts, right? And those kept adding up. And I think search realized that they were playing a game of like whack-a-mole, right? Because when you said, oh, fix classic short to go to these boots, what that would do is then change the search index to be weighted more on the product name. So hiking short would not go to shorts, but go to something else instead. Right. And when dress shirts would go to dresses, we'd be like, well, dress here is more of an occasion and not a product type, so please fix that. Then someone would type in evening dress, and it would go to not dresses anymore and go to shirts instead, because dress would now be more important than dress shirts. So they realized that they were fixing one problem, creating 7 other problems, and they started like manually patching it with just hard-coded redirects for specific terms, right? Mm-hmm. And it seems like that's what a lot of industry was doing at the time, and that's when they came to us in like late 2016, early 2017. They're like, this seems like some of your machine learning stuff could help. And I was like, yeah, I've been I've been asking. So it was nice. It was a voluntary, surrender. So we like it that way. So they came up to us, and we started then trying to understand the problem a little better. And we realized that English is a very funny language in the sense that many, many words are heavily overloaded. They have many different meanings depending on the phrase that they occur in. So the first thing we set out to do was kind of understanding search terms, taking in search terms and looking at customer behavior and building machine learning models that could create what are known as word embeddings. I don't know how many business stakeholders versus technical people are in the room, but
Well, let's see. Business stakeholders? Technical people?
oh, brilliant! All right, so word embeddings.
Investors?
Ooh.
Okay, we're safe. Go
All
ahead.
right. Word embeddings are effectively like mathematical, like think of it as a vector representation that kind of represents that phrase in some high dimensional, like manifold space, effectively, right? So what we were like, how do we represent these phrases in a embedded space, and then how do we also represent our products similarly so that we can search through our inventory by what the contextual meaning behind the term is rather than just by the words that occur in the phrase. And that was the very first iteration of the search algorithm that we went into production with, was the coefficients that we used to decide which attributes were important when looking in our search index were not just static and just does this word appear or not. We started modifying the importance when we looked into our search index, which is Solar in the back end, to weigh different parts of the phrase differently and look for it inside different attributes. So in dress shoes, we'd be like, look for dress inside the occasion attribute rather than the clothing type. But in evening dress, look for dress inside clothing type and see if the match occurs there and weight it accordingly. And what that gave us was a dynamic way of kind of extracting that contextual meaning from the phrases that we were seeing coming in from our customer base and adjusting effectively the score on the fly when the search came in. So we'd hit the machine learning algorithm, get the contextual meaning, run it through a process that we used to come up with adjustments to it to figure out how we could represent the output of the machine learning algorithm in a way that Solar could understand. Separate aside there, what we use for that is a genetic algorithm. It's a really cool optimization technique. We are very fond of them at Zappos. They've proven to be extremely successful in this particular area. We have a lot of fun with it. But that's what we use as kind of a translator. And that idea kind of lit a small flame because we saw fantastic results. We A/B tested it, saw a phenomenal response in engagement, in click-through rates, in conversion, all the fun numbers that the business likes to see. We were showing an ROI as a machine learning team, which I hear is not very common. So that was also fun to kind of prove to our business stakeholders that we weren't just a research team or a PR stunt. We were actually going to provide value to the core business, and that's kind of what.
Do you have embeddings for products, for shoes?
We do. So then we kind of evolved past just the phrase embeddings, and we started representing our customers in the same space. And then finally, we started using some deep learning to build neural nets from which we could flatten out the output and extract embedded spaces for the products themselves. And I think the most recent iteration is we're using autoencoders to create embeddings for the product. And I think the future state of what we're exploring is how to back those embeddings into the phrase embeddings. So not to try and represent phrases in Word2Vec or those more traditional text embeddings, but try and represent search terms in the same dimensional space as which you would represent the image of a shoe. And something we're experimenting with. But we skipped a few steps there, but kind of what we did in the middle from the phrase to what we're playing with right now is, if we can understand a phrase, can we understand a customer and also adjust the ranking accordingly? Where if I type running shoes, just be like, all right, how much are you really running? Versus a more athletic person that's serious about running versus someone who's just looking for a lifestyle sneaker. So understanding those nuances in who the customer is and what something means to them and trying to go through the same process. Again, millions of customers, millions of search terms, not something you can pre-compute. So something you need to do on the fly and be able to do quickly because no one, I can be like, hey, come and type a search term, wait 10 minutes, grab a coffee, I'll have the perfect results for you. No one's going to be okay with that either. So it's a balance of accuracy and efficiency there as well.
And do you have customer embedding?
Yes, we do.
Who keeps those clusters together?
We have not clustered them, and we avoid giving the clusters names. When we do group the embeddings together, we avoid naming them for logistical reasons.
And PR reasons.
You do have customer embedding.
Yes, we do have customer embeddings. Yeah, but we don't cluster them because we tackle the problem at a per customer level. So we do them separate for basket analysis and stuff like that, but which we democratize all these algorithms and embeddings and make them available via APIs to the rest of the company to kind of build products and solutions around, and providing education around what they mean and kind of how to use them so you're not misusing them. But yeah.
And we've got a lot of people who are potentially builders here who are doers. Who's on the team? I mean, who did you pull in and why?
So the machine learning teams, what we call Zappos Data Science is the name of the org. It's made up of a machine learning research team, a data engineering team, a kind of small R&D team, and a API team. The data engineering team is usually like solutions architects, cloud architecture. We are heavily invested in AWS, obviously, for, again, logistical reasons, and we use it a lot. And our cloud architects effectively find the most efficient ways to represent the data and build our pipelines and the flow, et cetera. Our API developers are the most disconnected from the machine learning process. They're pure software engineers that are kind of exposing these services at high volume traffic and being able to like expose these machine learning algorithms at scale to customer-facing stacks. The R&D team is kind of where new ideas are born. It's usually where a lot of the deep learning and stuff like that happens. We found that deep learning is very useful, of course, has tremendous use cases in e-commerce and a very powerful tool, but there's so many solutions in e-commerce that you can just solve with traditional machine learning techniques that, your decision trees, your random forest, your support vector machines, et cetera, that it's easier to hire for. So statisticians and machine learning scientists and data scientists that are more familiar with the standard linear algebra style machine learning solutions and regression modeling and stuff is what makes up the machine learning team. And they're able to kind of prototype solutions in a Python environment that our ML engineers are then able to help port over into the API team to expose out to the customer-facing stacks. So that's kind of the team composition. And there's a separate analytics team outside of this organization that handles the A/B testing, marketing analysis, kind of opportunity mining, the exploratory stuff that doesn't happen inside this organization.
So we'll have about 5 to 7 minutes for questions here, and I love the fact that you're asking questions, so keep doing that if you'd like. We'll leave some spots at the end too. So a couple of quickie questions. So you mentioned that English is a complex language. Is this just English language right now, and are there plans to change it into something else?
So there was a talk from the VP of AI at Facebook that was actually very, very interesting. And I think what he's referring to is Facebook's fast text solution when he says that a lot of these word embeddings, if you understand the meaning of a word in the context of where it occurs in a sentence or in a paragraph, you can actually do translation without having a corpus to learn from direct translation, because like a cat's a cat in every language, and cats do the same thing wherever they are. So if you learn the meaning of cat in terms of where cat shows up in language, you can effectively translate, stay static, the meaning, right? So I'm fairly confident that once, if needed, we could port and we would be able to represent some of these solutions in other languages, but we don't need to right now. And we do actually have a Spanish version of the website, so we are experimenting with seeing how this would port there. So yeah, it should be portable to other languages as well, these kind of solutions, for sure.
And we'll take a few questions in a second. So, in terms of the process, you've been at this a couple of years. What's been the biggest surprise, pleasant or unpleasant, in terms of your work or what you've learned?
I think it's how kind of aware the consumer base is. We are very customer obsessed at Zappos, which means we talk to our customers a lot, and they call us. We're on the phone with them for 3, 4, 10, 11 hours. I think 11 hours is the longest call that somebody was on a call with a call center rep at Zappos, and we just chat with them. And every employee at Zappos during a holiday season will go and get on the phones and talk to customers. So I've had a 2.5-hour long phone call, or maybe it was 3. I don't quite remember. It was a very long phone call where someone called with there was a play they were acting in, and they wanted to go through every scene and discuss what shoes they would wear in every scene. And I was like, you're going to buy these and then return them. I know you are, because you're going to use them just for this play. But it didn't matter. I talked to them. We went through each scene. They bought the shoes. And I was like, I hope you keep them, because, that was 3.5 hours of my day. But I love it, though. I love how customer obsessed we are. And the most surprising thing, to get back to your question, is that customers are reaching out in feedback surveys and trying to tell us how to improve our algorithms, using the word algorithm. We maintain a sizing algorithm as well, where we try and predict every customer's size in every shoe to reduce return rates. We've seen tremendous success there. And I've had a customer feedback that says, I think you're averaging my size with my daughter's size when you make this prediction in your algorithm. So I thought I'd let you know. And we're not just averaging the size, just for the record. It's a little more complex than that. But I just love that the consumer is expecting machine learning driven solutions, and they're kind of demanding an experience that is more intelligent in a way. And that's surprising to me, and I love it.
Really shows how much AI has taken root in popular imagination.
So, based on that last comment, do you incorporate any dynamic customer feedback into your process?
So we currently do not. That is something we are exploring, where we do have our user research team that's calculating NPS scores and stuff based off of natural language feedback. And I would love to start getting more proactive in the way we kind of incorporate that into our solutions, but it's not part of the workflow right now. It is in the sense that we look at the feedback, because again, that customer obsession is always there. We want to know what they're saying, and a lot of our features will emerge from things customers say to us, or when we're on the phones and someone's like, oh, this is horrible, and I'm like, oh, we can actually fix that. Sorry about that, and we'll just get on the roadmap, but it's not automated, no. So that's I think that may be a little bit of the secret sauce, because with a genetic.
Good question. Brought down the house.
So the algorithms that we maintain have a sort of like the fitness function, effectively, that we're optimizing is what we call our relevance score. I think I can go as far as to say that it's not individual products. It's definitely an ensemble that we're optimizing for, because there is no one right result, because it's like, who's the person, what's the term, right? It's difficult, and it's very subjective relevance. So it's some approximation of what we think is relevance, but it's not a single product.
So we build this, I'll get you in a second, but I want to make sure we get this in. So we build this as a success story. Can you talk just real quickly about what metrics you use to show success? I know you can't probably give specific numbers and dollar signs and like that, but what can you tell these folks to demonstrate the success you've had?
So I think one thing that we learned early on, I think this was a surprising piece, is that good search doesn't mean less searching. In fact, it can translate into more searching. What we have had to classify is what we would call a research, which is someone adding on words to the search term, where they are trying to effectively take the semantic meaning behind their original term and get it to a point where the lexical term would come back with what they're looking for, like running shoes, red running shoes, Nike, red running shoes, Nike, overpronation. All that additional stuff is what we try and learn. So when you come in and type running shoes, we guess the rest of that, right? So less researches, higher search engagement, obviously higher search to product click-through rates, higher conversion, higher revenue, depending on how successful you are. And these are all KPIs we've seen success with in our A/B testing, which is done by an independent analytics team. So we're not really just praising ourselves, just to clarify. But yeah, these are all metrics that we found are very useful in even longitudinally tracking how search is performing over time.
Please.
Have you tried or experimented or doing anything different between a full start and a non-customer from Semantic Search?
Yes, so that is something we are actively tackling right now. We have the cold start problem for recognized customers, unrecognized customers, but we also have the cold start problem for terms that we may not have seen before, or in fashion when the meaning of words change. Not something we're very successful with. We do have a few algorithms in place to try and capture the low volume search terms and relate them back to more popular search terms that we see more often, but we don't want to like pigeonhole those terms. We are exploring maybe intaking information from outside of our ecosystem and try to learn the meaning behind these terms in the fashion industry in general. On the customer side, we're trying some real-time session-based stuff. It's all very experimental. We're doing session replay right now to see if we can, how quickly can we understand what that particular customer's intent is in that sense, but nothing in production.
Sadly, we're going to have to wrap here. Time goes quickly. However, I am going to volunteer, Ameen, to stick around for a couple of minutes afterwards and take any questions we didn't get to. He's great and loves to talk about this, as you may have guessed. So I want to thank you for your participation and interest. I want to thank Ameen. He's a wealth of interest about this. So thank you.
Thank you. Appreciate
And
it.
thank you for participating.
Thank you.
Okay.